Hi, Thorsten. Welcome back.
Hey, thanks for having me again.
Today, about CloudFormation CDK, right?
Perfect. Sounds like a me territory.
Yeah. What we learned yesterday, that in one point of time, you started to help your clients migrate to AWS, right?
Yes.
And then we never covered how you found CloudFormation. So, what you actually did. So what was your first migration or how it looked like?
So our first migration was running one of the first German banks in AWS. So we had, it was a software company. We were building our own core banking software. It was microservices based on Java, messaging, and all the stuff. And it was running on a set of 8 or 10 computers in a data center. And they were like, there needs to be a better way to do that. This was 2012. And then we figured out, hey, there's AWS, and they have something called EC2 instances. And they just announced something like VPC. This was not there before.
Well, you said this was 2012.
Something around that, yeah.
No,
and then that's when they started. So VPC was just launched. So you could have your own private network with the machines and not everything public IP addresses. And then we started setting up some EC2 instances, deploying our software there, and it was clicking a lot in the console. And I was like, there needs to be a better way. And then we figured out, hey, there's something called CloudFormation, where you can specify your infrastructure in a JSON file, and it then generates your infrastructure. And you can make sure that your dev environment and your production environment look the same, including firewall settings and everything. So we migrated everything to CloudFormation and used it from there. It had a lot of bugs. It had a lot of missing features back then. But it was better than clicking around on the console. And there was no YAML. It was JSON only.
And it was released 2011, interestingly, CloudFormation.
Yeah, I think it was released in 11. The specification is 2010. September 2010. But we started using it in 2012, 2013, something like that. Mainly because of the VPC feature.
14 years ago.
Basically, yes.
Yeah, crazy. And so you started right away with CloudFormation or after clicking?
So we clicked around a lot, and then it was like, there needs to be a better way. Then we were like, should we write our own deployment code? And then we figured out, there's CloudFormation. Let's do that.
Okay. What I remember with the VPC, back then was some drama because AWS was very popular and lots of projects wanted to go to AWS. And I remember is that what VPC didn't support it or was a broadcast or multicast. So everyone is back then, was concerned because lots of Java shops, they used caches. The caches used, for cache invalidation or replication, broadcast, or multicast. And I remember this was or even messaging solutions. Was it before VPC or with VPC? You remember the time?
So multicast was added to VPCs way later. It was part of the Transit Gateway feature set. So multicast is only available on the Transit Gateway as a multicast host. So this, I think 2018, 19, something like that.
Okay. But you remember the drama, right? For the,
it was this discussion. I know we were running on Hazelcast a lot.
Exactly.
So we had a lot of Hazelcast stuff running there, which had interesting other effects on AWS. So I remember debugging for a week why our Hazelcast cluster was not coming up on AWS, but it was working on my machine. Until I figured out that they had a synchronization issue in their code. It only happened if you had one core. And all developer machines were like 8 core, 12 core, 16 core, whatever. It never happened. But EC2 instances, the T3 nanos, or back then T1 nano, had one core. So the service didn't start up because there was a synchronization lock in Hazelcast. Then Hazelcast added features like looking up autoscaling groups instead of using multicast to discover other nodes, which then was the way to go. Just give it a feature set and call the AWS API and check the autoscaling group list.
So you are in the interesting time. So you had to solve lots of problems, learned a lot back then, and and for me it was a crazy time because we were actually happy on premise, and lots of my clients wanted to go to the cloud, but they've asked why. They had no idea. This was like some manager decided to go to the cloud, and I said, okay, if you would like to go to the cloud, you will have to solve all the problems you mentioned now. And the question is why? I mean, at the end of the day, we will run on EC2 or somewhere on a machine somewhere else, but with no difference to now. So at least we should find any benefit, which came in my projects way later. So way later was obvious that some projects have to go to the cloud. But back then, people wanted to go to the cloud, but they had no idea why, So this was, the motivations of the bank back then, why they wanted to go to the cloud?
So the bank, what was us? So the thing is, the company structure was like 6 to 8 traders, some people in the back office, and around 10 software developers. That was the bank. And yeah, there was somebody in IT, but mainly being responsible for the 60 computers on site, like the trader computers and all the stuff. So whenever we needed something on a computer, it was like, yeah, we need a new server. Okay, we order one. Some weeks later, you get one. Then somebody needs to install it, needs to harden it, needs to set up everything. It took us like 2 months to get a new computer or a new server.
Okay.
Or then running VMs, but it was also another thing. So it was always up to us as developers to run that. So we did DevOps before it had a name, DevOps. And then we were like, there needs to be a better way to provision servers. Sometimes we just want to test something. We need 5 servers, but we don't want to buy 5 new servers. And that's why we decided, this cloud thing sounds great.
Okay, so there were pragmatic reasons. Okay, so you are small. My companies were, interestingly, some of the companies were quite large, and they had a perfectly working data center, And then, so okay, why? Just ship another container and we are done, right? So this was actually no reasons, but
this is your own data center. So we had a mandate that we need to have 2 data centers. So we rented a rack in Frankfurt in the Equinix data center. But the problem was nobody was on site. So whenever there was something like, another hard disk failed, which happened every several weeks because of the number of computers, we had to create a ticket at Equinix, send a new hard disk there, have somebody switch the hard disk while we're on the phone, and like, this cannot be real. Yeah. And so data center was always a problem for us because we didn't have the hands on it. We needed other people to have their smart hands, and like cloud really made that easier.
What's interesting is now with CloudFormation back then that it's the state, right? So I think back then, working with something like this were, because CloudFormation not about directly calling API, is more like expressing what you would like to have. You say, okay, I would like to have an EC2 machine, and CloudFormation manages somehow in the cloud that there's a service on AWS, and it changes or it verifies, reconciles your state with the given state and computes the diffs. This was, I don't know whether it was revolutionary. It was the same time like as Kubernetes, right? Because Kubernetes was late 2011. So that's interesting. Kubernetes came later, right? This would be interesting to check what was the release day of Kubernetes.
I think the idea of CloudFormation came from the software management, like Ansible, Puppet, Chef, that also were working in this declarative way to define how the machine should look like, and then extrapolating this to the infrastructure. Like, if you can tell me how a server should look like and then provision the software for it, it should also be possible for the hardware or the infrastructure to have a desired state and then reconcile to that.
And when Kubernetes came out? 2014.
Yeah.
3 years later. And what I thought the entire time that CloudFormation was inspired by Kubernetes, but CloudFormation was before Kubernetes, which is actually crazy. So this is because I thought Kubernetes came out with the reconciliation and state, and CloudFormation is the same principle, but CloudFormation is older. But what do I remember? I was in a Java e-commerce kind of projects, actually gambling projects in 2008. And already then there was Ansible, and there is a commercial version, I think managed engine, maybe not managed engine, but something like Ansible, but commercial. And this was already infrastructure as code, state-based code. You remember you have to make some research. It's like Ansible, but was commercial. So you had to buy it somehow. What tools were available? We had Ansible. It was quite old. What else?
It was the Puppet and Chef.
Chef, Puppet, Ansible, exactly. And there was commercial predecessor.
So for infrastructure, what also existed, I had used with another customer was Foreman, which was open source and basically Red Hat thingy. What was some kind of infrastructure, not infrastructure as code, but desired state management for VMs, like VMware, ESX, which then worked with Puppet and stuff like that. So the idea of describing a state and have the machine figuring out the way there, I think it's pretty common. And then there's different implementations. So there's Terraform doing similar things. But the big benefit of CloudFormation for me was always that they are managing the state. So CloudFormation manages the state automatically in the CloudFormation engine, and you don't need to care about state as with Terraform, storing it on a disk or whatever.
What my client used in 2008 was CF Engine.
Oh, yeah, CF Engine.
And whether it is also state-based? This would be interesting. Convergent manner. Yeah, this is also one of the main ideas of CF Engine is that changes in computer configure should be carried out in convergent manner. I think it is the same idea. CF Engine can run again and again whatever the initial state of the system and will end up with predictable result. So I think CF Engine was one of the first. It was 1993. Yeah. Wow. And on Oslo University in Norway. I didn't know that. What I remember in 2008, they used CF Engine, and I said, okay, no one knows that. It's too old. We should use Chef or Puppet. And Chef or Puppet, one of them, there was even Java bindings, or they run on JRuby or something, I remember. So which would be perfect for us. But this is an interesting insight that CloudFormation is that old, and CloudFormation was actually inspired by something like CF Engine or similar technologies, and not by Kubernetes, which is interesting.
Yeah. Definitely not Kubernetes. No, it was really old, and it was really cool to build stuff up. And as I said, there were a lot of bugs. So it was a regular thing that stacks got stuck in CloudFormation. You needed support to clean it up. And so they broke something. So it was pretty common that something didn't work. That's all fixed, obviously, now. But it was still interesting, but it still was worth having that declarative state. So yeah, that was running into the IAC World Infrastructure as Code in 2012, 2013. Yeah.
I just look up CF Engine. They're available on GitHub, and they have they're still around. There is you can even buy still the tool. This is commercial and open source. It is not that popular on GitHub, but there are still commits. CF Engine 3. So this is one of the oldest. 40 years old. 43 years old technology. Yeah, that's cool. Now the question is, you wrote the CloudFormation with JSON editor, or how you did it?
Yes. Text editor, JSON validation. Sometimes there were no plugins for IDEs yet for CloudFormation. It was just the JSON file.
So what do you use? Ultradit, or what was it back then? Or
so we were running everything on Eclipse. So we just used the normal text editor in Eclipse IDE. And yeah, it was just writing JSON, and it was easily like 2,000-3,000 lines of JSON.
You liked in the beginning. I think not. But if you learn the concepts, you liked actually the syntax in JSON and what happened, or
I think
what is your relation to CloudFormation back then? So
I did a lot of CloudFormation, and so I really loved what it was working, and it was worth the effort. And it was always like, there was no, it's a lot of text, but there's no unneeded text in any way, because every line you wrote there had a meaning and you needed it. There was no boilerplate. Obviously, there were things like for each was missing or is missing. And like, I want to have this server 8 times. I need to copy it 8 times in my JSON file. If I change something, I need to change it 8 times. And VPCs are still a mess to define, with subnets and route tables and route table associations. That's a lot of code. A VPC alone is like 900 lines of code in CloudFormation. But once you did it, it was there and it was fine to manage. So it was more like missing features, missing resources, that new service launches that were not reflected in CloudFormation, sometimes taking a year to end up. So we were always joking, maybe one of us should get hired by AWS on the CloudFormation team, fix some things and cancel again. Just get some things fixed.
Which would be actually not that bad idea, right?
Yeah, just get hired, fix CloudFormation, and then leave the company.
Yeah. No, I mean, seriously. So if you are a consultant, say, okay, let's give me a gig for 1 year or hire me and then fire me. I mean, this could be, if this is honest, offer from the beginning and it's clear that it's like this, could be sometimes in big company the easiest, because, big companies don't work very often with, singletons like us, single person companies. So maybe sometimes it was easier to hire me for 1 year and then fire me again, right?
Yeah. So I think we really love CloudFormation and learned a lot. And I still see that it brings a deeper understanding when out using tools like CDK I know what's happening. Been there, done that. I know why things fail the way they fail, because I really did a lot of deep dives into the behaviors of CloudFormation. And the great thing with CloudFormation is it's stable. So they're still running on the same specification version than back then. So they're still backwards compatible. If I take a CloudFormation template from 2012 and run it now, most of it will still work. And it's not about CloudFormation. It's more like, yes, T1 micro doesn't exist anymore. So you need to change some instance types, but the rest is still perfectly valid CloudFormation and working.
Which is amazing, because back then it was like 2012. It was not. I mean, it was a completely different world from software perspective. Have you ever got the idea to use Java and serialize Java classes to JSON back then?
No, we experimented a bit with velocity templates. To generate some things. So that was
which became API gateway, right? Just kidding.
We experimented a bit with using velocity templates to generate CloudFormation out of other snippets. So more like aggregating CloudFormation snippets together, but not having an object-oriented model on it. This was an idea that was then happening at Amazon some years later.
Because I found CloudFormation later, and whatever I did, I always try, thinking in Java. So, okay, how this could look in Java. So I immediately got the idea to read it in Java, because then it would make more sense for me if I see the objects. But then I found CDK actually. So, okay, it's already done. And then first I thought CDK is more like SDK, but then I understood that it serializes to JSON. I said, okay, cool. This is matches well with my world. How this is working? So this is a service with a state. I guess the state is in the bucket, right, in CloudFormation. So maybe how CloudFormation bare metal, how to call it, the bare CloudFormation is working.
So we can only assume some things of it because it's a managed service, but effectively it's storing the service, the state in the CloudFormation backend service. So whenever you upload a new template, so a new JSON file or now YAML file, I think that was coming in 16-ish or something. that you can now write.
You like YAML?
I think for humans, it's easier to read.
Oh, really? Read, yeah, maybe read.
Yeah. And writing is hard because of the specialty.
Yeah, exactly. So, but I write it all the time. I never have to read it actually. So I try to avoid YAML as far as possible.
Yeah. So you upload a new template to CloudFormation. It then compares that to the old template. Mm-hmm. It figures out what the changes are. Mm-hmm. Nowadays, they released a feature some months ago. Now it checks also that changes to the reality. Mm-hmm. So if one of these changes is already in the real resource, mm-hmm. and it's doing a three-way diff. So it's comparing your new template, your old template, and the reality, mm-hmm. and figuring out what needs to be done. Mm-hmm. And with that information, CloudFormation is then going on doing API calls on your behalf mm-hmm. to the different services, like creating a security group, changing an ingress in a security group, creating a Lambda function, whatever. And all the results from these API calls are then stored back into the internal state. Mm-hmm. And if everything's fine, it just, stack update complete. And that's it. And the big benefit of CloudFormation for me is that it has all the failure modes included. Because creating that part, figuring out what to do and executing API calls, that's easy. You can vibe code that in a day now. Yeah. The problem is what happens if it goes wrong. Mm-hmm. And that's where CloudFormation excels. It's even way better than Terraform. It rolls back. Mm-hmm. So it makes sure to go back to the initial state before you started your operation. Mm-hmm. So with CloudFormation, you always get either the current state mm-hmm. or the new state. Mm-hmm. Nothing in between.
This is what if I found CloudFormation on AWS, I couldn't get any benefit of Terraform. Because, the idea that you have Terraform and this is multi-cloud, I mean, the resources are so different, between AWS and Azure. So I think forget it completely. And the syntax of Terraform is not that hard. You can learn it. So, I mean, in a day, developer is also the problem. Now they have a kind of a for loops, but back then this was also not available. So for me, Terraform is okay. Maybe it's interesting if you have, private cloud, OpenShift, whatever, then it's interesting. But for AWS, I never got the idea. And what I didn't like is that I have to learn something twice, because for me, CloudFormation is this what AWS has, right? And even if we didn't know some certification, compliance, whatever, it's actually pretty cool because CloudFormation and CDK come from AWS. And if you go to AWS Cloud, there is nothing else to justify, no licensing issues like OpenTofu, Terraform, whatever. So the entire Terraform, I actually have to say, never got it. And if I ask questions, the only answer I got is because we are independent from AWS, which is not true at all. So other reasons were not available for me. And another problem what I see with Terraform is if you start with Terraform, there's actually the state is stored on your local machine, which is crazy. Yeah. So you have, if you would like to work in a team, the first thing you have to do is to try to encrypt the state somehow, because it can be sensitive, and also to put it somewhere where everyone has access. Okay, there are some modules and stuff, but you have to do this. And I was in project, they had no idea, so they run Terraform on EC2 machine, on a single one, and the state was stored there. It's like, okay, you are crazy. Why you are not using CloudFormation? Man, it's way easier. It is already done. Yeah, I mean, who cares, right?
Exactly.
Do you see any benefits of Terraform? Because you're really, so objectively, I mean.
So depending what you do, sometimes it's faster because of the consistency. So it doesn't have the same consistency guarantees than CloudFormation, which makes it faster.
How faster?
It creates stuff. It doesn't care about rollbacks and things like that. And where I'm really using it is when, for the landing zone. Sometimes I'm using Terraform when I need to manage AWS resources, but also things like an on-prem connection or GitHub repos or things that are connected to AWS, but not AWS. Mm-hmm. Then you have the benefit that Terraform is talking to multiple providers at the same time in your code. And CloudFormation is only AWS resources.
Yeah. So you can use Terraform to talk not to just AWS, but for the others. Yeah, absolutely obvious. Yeah, and a landing zone. I created I created even AWS accounts with CDK provisioning. You can do everything. So because the API is available, so this work well.
Totally. And it's for me, it's often the platform teams that need some connectivity to outside of AWS, like configuring an on-prem router, configuring a direct.
Absolutely.
And that's the point where then I switched to Terraform.
But one question: if you have such a thing, and lots of CDK or let's say CloudFormation, we don't know what CDK is now, but for CloudFormation, I could actually create my own custom resource to manage the external thing, right? Wouldn't be this a better approach for consistency?
It depends on how much you want to do. So, looking, for example, at GitHub repos, there's so many resources to manage.
Okay.
You don't want to re-implement that in custom resources. I would really love for AWS to step up and say, yes, we are just providing more resource types for non-AWS resources. That would be great, because I would love to use CloudFormation for that, to configure things in my AWS ecosystem that are not my AWS account, but tools I need for that.
Could be pluggable, right? Open API or whatever.
No, it already exists. You can provide your own resource types in CloudFormation, but just nobody does it.
Okay.
So,
yeah, fascinating story now, I have to say, because you are the ISC expert, and Terraform, I have exactly the same view, which is good, because I couldn't believe that lots of my clients using this without any benefit, and how they use it was actually crazy.
Yeah.
Okay, so we have that. We have CloudFormation, and if we use CloudFormation, there's actually nothing needed. It works out of the box. We covered, I think, the life cycle more or less. Maybe Drift, because you said there's a three-way diff, but Drift was always available. So they could identify Drift. What Drift is if someone clicks on your resources and changes the state of the real world, how to call it real world state? I mean, this resource state or cloud state. Then you have drift between the state known by CloudFormation and the real world, right?
Yes.
How you call it real world? Is a proper name for that? So like, the real state of the resources or whatever.
The physical resources of the CloudFormation.
Okay. Physical. Okay. The CloudFormation is the logical state and physical state. These are the terms. Okay, perfect.
Yeah. And so drift detection was added, I think, in 2018, 2019, something like that. And it helped. In a perfect world, you don't have drift because nobody has write access to your AWS account.
Exactly.
Pipeline has. But you don't have a perfect world. So there will be drift at some point. Drift detection was helping you, but now with the three-way diffs, you don't need to run a drift detection manually before that. It just shows up when creating an update. It's just showing you the three-way diff, which makes it easier to use. It's a UX improvement. It's not fundamental.
Yeah. My impression back with the drift was it was sometimes too fine-grained. So sometimes even if you change, tags or whatever, it showed you stuff which didn't matter for that, right?
Especially, it does not cope well with defaults. So when you don't specify something in CloudFormation, the resource gets a default value. But then drift detection says, it has this value, but CloudFormation doesn't have a value, which is a drift. So no, it's a default value.
Exactly. Yeah, perfect. Okay. And the question that I forgot to ask back then during the Eclipse days, your Eclipse days, is you had something like GitOps already that it run on Jenkins and automatically, push the CloudFormation state on every commit?
Yeah, that was effectively the thing. So we were running our own Git servers and then pushing to them, having Jenkins running and then calling AWS. That's exactly what I mentioned with the Jenkins plugin. So I built a Jenkins plugin to do the CloudFormation updates, create rollback stuff. So all the life cycle of that stuff was a Jenkins plugin I built, and it's still around there. And still,
was it hard to build it, or?
As always, the first steps are easy.
Yeah,
it got really problematic with agents. So if you have a Jenkins multi-node setup, because then it's very interesting where the credentials are coming from. For AWS. So are they stored on a master node or on the worker node? That was always a bit interesting thing. Otherwise, it's not that complicated to build. And then maintenance comes in, adding more and more and more features to the plugin.
Yeah.
And now so many features in there that I like, oh, I shouldn't have added that.
Okay.
And nobody should be using Jenkins anymore, but it's still very popular. And I'm getting a lot of issues like, I don't want to do that anymore. Please get rid of Jenkins.
Mm-hmm.
So if anybody out there is using it and wants to take over the Jenkins AWS plugin.
Mm-hmm. What I will do in your case is just say, okay, this is a paid support for your plugin on GitHub. And if you say, even if you don't need the money, you can donate the money or whatever, right? But then you will all filter out all the, requests where they say, okay, it doesn't format correctly, and just, sometimes could help such a thing. On back then, what's the difference between business logic change and infrastructure change? You know what I mean? So if someone performed, let's say, just changed Java code, which was pure business logic, your CloudFormation Jenkins still run, or had you made a difference between infrastructure changes and business changes?
Back then, we made a difference because we had built our own provisioning tool for our Java projects.
Mm-hmm.
So we used the CloudFormation repo, the CloudFormation code, and the Jenkins only to manage the infrastructure, like firewall changes, creating new EC2 instances and things like that.
Mm-hmm.
And software changes were then delivered by our distribution mechanism. So we packaged all our Java artifacts in RPMs, so the Red Hat Package Manager, and shipping them to the machines and doing YAM updates there. Mm-hmm. So the update itself was running using software artifacts and not using CloudFormation.
Mm-hmm. Oh, nowadays, there's no difference.
Nowadays, for me, there's no difference. Even 2 years ago, or 1.5 years ago at reInvent, we gave a talk about everything is a change. So there is no difference.
You gave a talk at the reInvent?
At reInvent.
What's the title of the talk?
It was the Developers Toolbox. We can put it in the show notes. The Developers Toolbox, so CI/CD. So it was more like beyond the normal pipeline, what are things that come if you have your first pipeline running? What are the deep dives? And basically, the summary is everything is a change. And it doesn't matter if it's business logic change, if it's configuration change, if it's a secret change, if it's an infrastructure change. There is no difference. It's a change and it's getting rolled out. Mm-hmm. And you don't care if you change the business logic of your Lambda function or the configuration of your Lambda function or whatever.
This is the same here. So this is actually what if I started with serious AWS projects. So what happened is I got additional folder in my microservice called CDK, and on every change the CDK ran, CDK deploy, and as well as the business logic. And I needed this always because for end-to-end tests. So what happened is I provisioned the infrastructure first and then run end-to-end tests in dev environment automatically. And I always did it. And back then with application server, we did the same. But I was not sure whether this is, the perfect approach. But this is why I ask you about your talk, because you seem now to do exactly the same. And there was a term, self-provisioned runtimes, right? And there is something like this. My understanding is, I don't know who coined the term, but this is like, you provision the runtime first and then run the business logic as well, right?
Exactly. So what you mentioned is exactly, I'm doing the same, but the other way around. Mm-hmm. So I don't have a CDK folder in my projects, but CDK is running at the root of the folder. So all my projects are CDK projects, and they have a subfolder for the application.
Oh.
Because the application is just one artifact of my infrastructure.
Yes.
And that's why the CDK code is basically the root of my project. It's infrastructure, it's configuration, it's applications, everything's part of that CDK application. And then there's a subfolder for my app. And if I have 2 microservices in the same application, it's just 2 subfolders. So
interesting. So for me, it's a little bit different. So 2 microservices, two CDK folders inside your business logic, but
it should. Yeah.
For me, it's a different. I have also an additional GitHub repository, and which provisions the pipelines. So, for instance, I have some base infrastructure in most projects, and this is usually multi-account. And I have code build, code pipeline, code star to connect to GitHub, and this has to run first. And
that's fine. That's fine. But in the application itself, for me, it's CDK is the root, and then my application, being it a Java application, a containerized PHP, or whatever the customer has, is an artifact. So it's a folder in my CDK application.
Interesting. This is the other way around. So I have to think about this. But for me, it worked perfectly. But your approach is also interesting. And I use Java for everything, which has interesting symbiotic relations, because I could, at any time, have no shared enums, shared constants. It would work perfectly. Try to avoid that, but it would work. So I'm still thinking about how to unify that, because what I don't like in Java are super poems and jar dependencies between projects. So this was always problematic and misused. So I try to avoid that.
Yeah. So especially if you're running containers, the approach of having the application outside and CDK in a subfolder has interesting side effects, because if you then build or run Docker build in the parent folder to package the application, it's trying to circularly package the CDK application that is now packaging in itself, which had some interesting side effects. If you do the other way around, the CDK application outside and the app in a subfolder, it's just easy because you just zip the app folder.
Yeah. Okay. Containers, I would say 95% right now is serverless completely, Lambda. And in rare cases, I use ECS Fargate, where Lambda didn't work, or Need didn't work. It was already there and we had to use it. In this particular case, Quarkus does the build. This is interesting. So the Quarkus
is fine.
Yeah.
But because if you're using CDK to build and it finds itself on the Docker build path, some weird things can happen. That's why I try to avoid that it's CDK is inside the thing that it's in context.
Yeah, and it was reasonable that Quarkus built that, because the Quarkus is does the optimization. So it just created. I remember it created that. Then I got the push was happening in the pipeline to ECR, and what I did in ECR, I registered event bridge event, which automatically reprovisioned then the ECS Fargate. Or not reprovisioned, told the Fargate, hey, go away, just go and update the application. And I never used the AWS deploy, I think, right? So this was...
for me, all that is happening in CDK. So CDK is also doing the versioning, the pushing, because the asset system in CDK is really great. But I think now we should do the segue about what is CDK. Exactly, that's the thing. So CDK was the idea of CloudFormation is great, but we want to have more magic. We want to have modules, constructs, and so the combination of a lot of resources together into one abstractions, and using object-oriented programming languages to do that. And that's why in 2018, 2019, CDK came to existence.
Were you from the beginning there?
Yes, I was in a beta, so not the real beginning. So CDK began at Amazon, not AWS. It was a team at Amazon that needed to build reusable infrastructure for other teams. And they came up like, we don't want to build that in CloudFormation because of it's same, but different for every use case. So they came up with the idea of CDK. In the beginning, it was written in Java because everything Amazon is doing is Java, or was back then. And then they figured out, that's a general problem, not only for us. So we could make it a project or a product. And they pitched that idea and the team then moved from Amazon to AWS to develop that tool as a product.
Okay.
And then they switched to TypeScript because that was basically a more popular language in 2019 or 2018. And at that point, I also got some information about that project, talked with the team, tried it out, immediately loved the idea, what they're doing. So we were trying that out in a beta way before it was publicly launched. So CDK 0. something.
How AWS found you?
So it's part of the Hero program. So
but how they knew that you are involved with CloudFormation?
Oh, they knew. We talked a lot about CloudFormation and the problems of CloudFormation.
They submitted a lot of issues. This is how the relation happened.
I talked a lot with them about all the stuff, and they were like, "Oh, you're doing that dev tools and IAC stuff. Maybe you're interested in something new we're building." And yeah, that's when they approached me about that, showed me the tool, and was like, "Yeah, that's interesting." And then 2019, the first version came out in public. It was June 2019. CDK 1.0. And and that's where the story of CDK began. And then there was changes, CDK 2 at some point, and now we are at 2.236 released last week. So and that was a journey on CDK.
But if you started with the CloudFormation, I mean, usually you would just use it in AWS. You are one of many accounts who are using, CloudFormation. So what you maybe did, you ask questions, how you did it. You just went to GitHub, or you had, your technical, how to call it, your ping the TAM, or how you interacted with AWS back then. Because in one point of time you had, direct access to CloudFormation team or to the developers, or how it happened back then.
Back then in 2012 and then the following years, it was talking to account managers, creating support tickets, everything is broken, fix that.
And how you created the tickets back then?
Sorry?
Via the AWS console tickets? So
support tickets, yes.
Okay, and because of the support tickets, they knew you because, the annoying developer again,
sometimes, but more like, so CDK in 2018, 2019, I was a hero back then. So
this is clear. But it was interesting how you established the relation to AWS, with CloudFormation.
Yeah, with CloudFormation, it was support tickets. And obviously, because we were one of the first banks in Germany, they were very interested in having us as a customer, because this was their story about, regulated industries can run on the cloud, which was nothing somebody thought of being possible in 2012, 2013. So despite having I think we spent less than $1,000 a month on AWS, but still we had support and account managers and SAEs and everybody being there for us every day, just because they wanted to be this a success for their story of having a regulated industries. So that's why we got fast access to service teams for problems.
And actually, if you think about this, a regulated industry should be actually only in the cloud, because what regulation means. There's this kind of compliance, how to call it, tests and reviews and lots of documents. And cloud has an API, and they can deal with the entire regulation, and they have the resources to be regulated or how to be compliant, certified, or whatever. All these certifications happen between the certifying entity and the certifier or whatever, and then it's certified. So this on paper certified, done. And then when you do as a business developer, you just certify your business logic, and you then have to recertify the infrastructure because it's already certified. So I would say, actually, nowadays, we should spend more time to justify why you are not in a kind of a cloud which is certified, and you try, to certify yourself. Because I would say it is really hard to be to run your own infrastructure which is completely compliant. And I was a few years in the project. I was asked, to be the architect in highly regulated industry, and they expected to do private cloud for them from scratch. It's like, I cannot do this. So I say, if I say yes, we spent 3 years just for the infrastructure to do it everything properly, certificate rotation, secrets management, whatever. And in the cloud everything is done. So it is already done. So I would say now it's your decision, but it would be really bad if you decided to implement everything from scratch. So this is my take, and whether the cloud is really secure or not is a different question, right? This compliance and regulation is not what it really is. So then how many papers and certificates you have to run your business, right?
Yeah, and change management. So one of the biggest regulations, change management. And in the cloud with infrastructure as code, change management is basically a byproduct. Because if everything you do is infrastructure is code in a Git pipeline, your change process that you need to document is just showing the Git history.
Yeah.
It's done. Who approved it? Who merged it? Who did what when? Everything's in Git. It's the only way to provision something. You have logs and CloudTrail and CloudFormation history for everything.
Mm-hmm.
If you do it on-prem, welcome to documentation horror.
Yeah.
Because to make sure and prove how every artifact got into production. Nobody is doing that.
Yeah. And what I also remember, or if you get serverless, it gets even better because you don't even have your own infrastructure then. But what I remember back then is there was a regulated project. They asked me to help, and they use Spring. And I asked, what's the problem? Because I was not aware of that. But the problem was they had so many variations of the dependencies. So if something ran to production, they couldn't tell what's inside, because there was just one jar, but what was in the jar was hard to tell. I never had a problem because of application servers. We didn't have anything. So the application server, my clients bought support for the application server, and the war was just the business logic. What's actually, funny enough, very similar to serverless right now. This is why I like serverless, because it maps directly from application servers to serverless. People call me crazy, but exactly, so serverless is exactly what I like to have. This is all the years, we separated the infrastructure as application server, and the web application archive, the war was the business logic, and it's exactly the same now in serverless. One step further because we had better APIs and better automation, right? But change management, you are absolutely right. Back to CDK. So so you were involved from the beginning, and CDK has the notion of a stack. This is for me like a infrastructure microservice, right? This is something stateful, and this is like one thing which is loosely coupled, should be, to other stacks. And the idea is that the stack can be independently deployed, right?
Exactly. So one stack is the atomic unit of a CloudFormation and CDK. So everything in one stack is either version 1 or version 2. If you deploy it, there's no in between. So that's the atomic boundary of a deployment. If you have two stacks, one can be deployed while the other is not deployed. That can happen with rollbacks and stuff. One stack is always an atomic thing. It's deployed or it's not. So that's your boundary of things that have a... So all the resources that share a life cycle should be in one stack, because that means they are created together, they are destroyed together, they are updated together.
What I try to do in my applications is with CDK is I try to put, stateful resources like S3, DynamoDB, certificates in one stack, and the business logic in another stack, and they are loosely related to each other. And especially Cognito is a little bit problematic, because whatever you change in Cognito, it tries, to redeploy the entire thing. So it's not. Is it a good approach?
I see that sometimes, and then there's also a lot of documentation out there that says this is a good thing. I don't like that approach.
Okay, what do you do?
Exactly about the atomic boundary. So my whole application should be one atomic thing. It's deployed or not.
Okay.
That's why I put everything in one stack. But then I don't break my stateful resources by accident. Doesn't hold, because CDK is always deploying all the stacks. So even if you change something in your code and you break your stateful stack, CDK will still deploy it, even if it's in two stacks, because it will deploy both stacks. So you can still break your stateful resources, even if it's in different stacks. Big problem is relations. So all your business logic normally needs relations to your stateful resources, like to know there's rebucket name, the Cognito user pool ID, and all the things. And it's doing that then using CloudFormation exports, CloudFormation references. And now you get tightly coupled two stacks. And you cannot change one because it will break the other, because it's two operations. So you're going to reference hell in CloudFormation. If everything is one stack, it only needs to be reconciled at the end of the operation. So at the end of a stack update, it needs to be consistent. But there can be inconsistencies during the deployment. But if you have two stacks, it needs to be consistent in the middle of the deployment after the first stack. And this is sometimes very hard to do. So and then you end up with things like a security group or a configuration in your stateful resource was changed because that stack update succeeded. The deployment of your business logic did not succeed. It's rolling back that change. And now you have a not working environment because you have the old version of your application code talking to a new version of your stateful resources.
Mm-hmm. What I had good experiences with Cognito in particular, and what I did is the stack was Cognito was in one stack, but there were no dependencies between stacks. Instead, we stored the names and so forth in parameter store. So there's like a loose coupling. So we could redeploy Cognito, and we have to rely on the names. And
that's fine. Mm-hmm. But then I would put it in a different application in CDK.
Maybe, okay. Mm-hmm.
Because then you just treat it as two services.
Yes.
And that's fine. This is my Cognito. I have a separate repo for that. I have a separate CDK application for that. And it's just deploying Cognito. This is my application Cognito. Mm-hmm. And then I have another application that's using that as a dependency. Mm-hmm. And I specified IDs as parameters. Totally fire, because now you're treating them as two microservices with their own lifecycle.
You are right, actually, because it can be treated this way, because usually Cognito is used by two applications anyway. One is like onboarding and the other one. So from the architecture perspective, it would be cleaner because you're right. It's just very similar to microservices, actually, right? So if you have two microservices, never share jars between microservices because hello.
And for me, it's one CDK application should be a group of resources that share a lifecycle. Mm-hmm. If I create them together and if I destroy them together, they're one CDK app and one stack. Mm-hmm. If not, they're two.
Mm-hmm. So, and from the programming model in CDK, so I only know Java because but all are similar because they are generated from the JSI JavaScript.
Exactly. So CDK itself is written in TypeScript and it's always running on a JavaScript engine. Mm-hmm. And if you're using Java, you're getting generated facades, basically, that are then using remote procedure calls to call the JavaScript code. Mm-hmm. So you get a Java interface, but it behaves exactly the same. So there's no different versions of CDK. There's only one feature set of CDK, and there's different APIs. So basically, you have a Java API to the CDK, but the CDK itself is still running in JavaScript.
Mm-hmm. Similar like Python. If you do use Python, it will be the same, right?
For Python, Go, whatever you use, it's using the same code. Mm-hmm. That's why the JavaScript version or TypeScript version of CDK is a bit faster because it doesn't do these remote procedure calls all the time because it's running in the same node process. Mm-hmm.
And but it's a local call, right?
It's everything local.
Yeah, exactly. So the Node.js and we do CDK deploy. It is just the call between Java and the local JavaScript runtime. Exactly. Okay, so if you start with Java, you have to start with the application, not the stack. So application, and then you pass the application to your first stack, and the stack is visible as CloudFormation stack, I think, right? Yeah, this is the same name. And it is visible in the CloudFormation tab in AWS. And then you can create so-called constructs. And they are low-level constructs. This is the low-level constructs. What I do is you can look up the structure because there is, I don't know how it's called, but there is a API documentation of CloudFormation, and you see exactly the structure of the API. What's the name of that? You know what I mean?
There's a CloudFormation specification, or the resource property reference, I think it's called in the console. And yes, the low level or the L1 constructs in CDK are exactly that. They're just an object representation of CloudFormation. So there's no abstractions, there's no name changes. It's exactly the same as CloudFormation, just Java or TypeScript instead of JSON or YAML.
Exactly. And this is actually, this was my way because I didn't care whether something is documented in Java or not. If I was not clear, so it's pretty cool. I look up this in the CloudFormation specification, and sometimes an attribute was not exposed. So I could call it anyway by a trick. I forgot what I did, but it's possible in Java to call it anyway, even if it's not exposed. And this is how it works. So what it means is you have the stack. It is the outside object, and inside you have constructs, and everything gets serialized to one big JSON in this synth phase.
Exactly.
And this is like Java JSON persistence. This is what happens behind the scenes, and this JSON is then uploaded to AWS, right?
Exactly. So after synthesizing, there is no difference in using CloudFormation or CDK because it's just doing a CloudFormation update with a new template. And CloudFormation technology, or from a deployment technology, does not care if it was written by CDK or you being crazy in Notepad++ and writing 3,000 lines of JSON.
And you can actually look it up. So if it's a synth phase, you have the JSON, and you can look at this, what actually happened. So it's not very readable, but helpful for debugging sometimes. I will have to reinvite you back to talk more specifically about Java and what I'm interested in now, custom resources, when to do them. And what I forgot to mention, you wrote also a book about CDK, right?
Yes, together with 3 colleagues, we wrote the CDK book. It's just called the CDK book.
The CDK book?
Exactly. And we talk about a lot of the special things in CDK. So it's not an introduction to CDK and this is how it works. It's more like how do assets work and how do pipelines work and a lot of the special things. We might need to do a revamp of it because it's now 3 or 4 years old. Yeah. But the concepts are still true. So it's still true, but there are some things that are new that could be part of it. Yeah. We were thinking about a V2. But yeah, it's there, it's out there, and a lot of people are very happy with it. Because
what I'm interested in the next time, to take a look more on Java. This is what I'm doing all the time with CDK, and how we could create a custom resource or whatever makes sense, how to extend maybe the Java part, and what would be an useful contribution, and just talk a little bit more about Java CDK and custom resources, maybe crazy stuff like how it's called self-modifying pipelines or self-mutating pipelines, and crazy stuff like that. Maybe testing. CDK tests, also interesting part, how to test the entire thing, because there is you spend also some time, with CDK tests, how to test it, and test approaches. So there's enough to talk, I think. It's a cool thing to just build your infrastructure in a way that especially other people and you in 6 months are still able to read. I think that's the thing. Reading CDK code that is a year old is way easier than reading CloudFormation code that is a 1 year old, because what's going on here? What I forgot to mention is what I like CDK is you write the constructs and everything is on your disk. But if you click in the console, what sometimes happens is that behind the scenes, new roles or whatever are created which you don't see with strange names. And with CDK, you have more control, because you can say everything is tagged your way. You can use your names, so it's easier to find which was created. So this is also a huge point for CDK and CloudFormation. Yeah, I think the huge point in CDK is that it's creating stuff for you that is easy to build. In CloudFormation, and you have control over names. And you have a big part of my project is not the logical names, but you can add new names.
But with CloudFormation, you would need to specify the role by yourself.
Okay.
So you would need to build all that stuff on your own. Yeah. And with CDK, it's done for you. Yeah. Okay. The name of the company is Thamos, right? Thamos, exactly. Exactly. And people can hire you to help you with AWS, help them AWS infrastructure, just build services. And you would love to do some Java again, right? What I guess. Also doing Java. I'm coming from a Java background, so.
Yeah. But, and you have to look, Java 25 is really great. So I really enjoy it more and more and more. I always enjoyed that. But now it's really crazy times how nice it is. So thank you a lot, and see you next time.
Yeah, thanks for having me.